Hello everyone and welcome to lesson 2 of Algebra 2. Today's lesson is going to be focusing on foiling, distributing, and factoring. Honestly, today is going to be one of the easier lessons out of all of them, but nonetheless super important lesson today. If you don't know how to do this, then there's no point in continuing the next 6 weeks because we're probably going to be using this skill all the time. So first let's start with foiling. Foiling is just an acronym that stands for first, outer, inner, and last. And it describes the way you multiply these things together. Like for instance, when you have x minus 2 times x plus 5, this is the order we're going to follow. First, you multiply the first terms together, so x times x. X times x is something we need to know that becomes x squared. Then we do outer, so x times positive 5, which is plus 5x. Then we do the inner, negative 2 times x, which will be minus 2x. And then last, which is negative 2 times 5, which is minus 10. And then all you got to do is combine like terms. The only like terms I see here is 5x and minus 2x. So the final answer is x squared plus 5x minus 2x is 3x, and then minus 10. And there's our answer. That's how we FOIL. Hopefully this sounds familiar. We're just going to do a few examples of this and then move on to bigger and better things. So let's do some practice. X plus 7 times x plus 9. Again, same idea. You multiply first, outer, inner, last. X times x again is x squared. Then outer, x times 9 is plus 9x. Then the inner, 7 times x, so plus 7x. And then last, 7 times 9 is 63. Notice as I go through here, I see a lot of students do this. They'll draw all these lines right away. They'll draw 1, 2, 3, 4. Don't draw all the lines at once. The reason why you're drawing the lines is to keep track of what you've already got. So in other words, what I'm saying is draw one line, write the term. Draw another line, write the term, so on and so forth. Anyways, now we have 9x plus 7x. That's going to be x squared plus 16x plus 63. And there's our answer. And now for number 2 here, what I'm going to do is I'm going to do something weird. I'm going to add these in a random order to show you that the order does not matter, that you added it. In other words, what I can do here is I can do first, start with last, if I really want to for the FOIL. I can say 3 times negative 10 is negative 30. Then I can do inner if I want to. So 3 times x is plus 3x. Then I can do outer. X times negative 10 is minus 10x. And then x times x, again, is x squared. So plus x squared. And again, I got to combine like terms. So I'll get negative 30 minus 7x, because 3 minus 10 is negative 7, plus x squared. And then for the final answer that I'm actually going to circle, I always like writing it from highest degree to lowest degree. That means I like to write it as x squared minus 7x minus 30, because that's what you're going to see in your algebra class. It just makes our lives a lot easier when you have it written in this form. Any questions with any of the first few? For those of you joining late, we're just doing foiling, something that you probably remember from Algebra 1. If there's no questions, let's continue. The next thing we're going to talk about is distributing. The good news is distributing and foiling are basically the same thing. Basically the same thing. And that's great because if you know how to FOIL, then you probably know how to distribute. And then the fill in the blank here, the key to distributing is we want to multiply every term from one factor to every term from the other factor. And we'll see what I'm talking about in this example below. How many multiplications will this one have? Well, here's the thing. If you want to know how many terms you're going to have, like for instance, the last few we just did, there were 4 terms. 1, 2, 3, 4. And then we simplified it down to 3 terms. But what I'm saying is the reason why we had 4 terms at first is because you had a 2 term times a 2 term, and 2 times 2 is 4. In other words, in this example right here, x plus 4 times x squared plus 2x minus 1, if you want to know how many terms we're going to have, this is a 2 term, and this is a 3 term, which means you're going to have 6 terms total. And then you'll simplify, you'll combine like terms, but expect 6 things you're adding and subtracting when you distribute this. Does that make sense? Okay, good. Now, the next thing I want to say, you can write it in this blank space on the right here. The next thing I want to say is you've probably heard of a few vocabulary terms before, but maybe you don't know what they mean. I'm talking about monomials, binomials, polynomials. You've probably heard these words before, but you don't really know what they mean. So I'll explain it right now. A monomial simply means one term. And an example of that would just be, let's say, x. That's a monomial. It's just one term. A binomial simply means 2 terms, as the name implies. And a binomial can look like this, x plus 3. Notice there's 2 terms. Every term must be separated by a plus or a minus symbol. Then you have trinomials. Trinomials, I bet you can guess what this is. That's right, 3 terms. That's going to be, for instance, 2x squared minus 6x plus 1. Notice 3 terms, 1, 2, 3. I don't care about the coefficients and the x's. I just care about how many pluses and minuses I have here. And then the last category, I could do this for a while, right? Like I don't even know what comes after trinomial. I guess quadrinomial, pentanomial. They don't even call it that, so don't worry. The only other word you need to know is polynomial. Polynomial. And this is where the pattern's going to break off, because polynomial does not mean 3 terms. It just means more than one term. More than one term. So in other words, a binomial is a polynomial. A trinomial is a polynomial. Literally, whenever you have something separated by a plus or minus, even something as simple as x plus 1 is a polynomial. And the reason why that matters is because I want you to know the vocabulary so we can use more complex mathematical language so we have a better vocabulary to describe what's going on here. Because even if you don't like this vocabulary, even if you think you'll never use it, I promise you that your teacher's going to use it next year. So let's be ahead of the game and let's know what our teacher's talking about. So now we're going to be combining like terms. And what I mean by combining like terms, you can only combine terms if they have the same number of x's. So let's see what I'm talking about with some examples here. For the first one, 5x plus 6x, they're both just x. You know, there's one x, which means they can be added together. 5x plus 6x is 11x. They're like terms. Same thing here for the next one, x squared minus 3x squared. I can add or subtract these because they're both x squared. If, for instance, this was instead of x squared, let's just say it was x cubed for a second, then I could not add them or subtract them. But since it's x squared, we can. Remember that whenever you don't see a 1 in front of, or anything in front of the x squared, there's a 1 there, an invisible 1. And 1 minus 3 is negative 2x squared. Now for the next one, you really got to think about this one. 2x squared minus 5x plus x squared. The only 2 you can add together is 2x squared and this 1x squared. That will give you 3x squared. And then what do you do with the minus 5x? Well, you just put that at the end, just like that. And there you go. Now let's see how we multiply some of these. Like for instance, x times x squared. What's that going to be? Well, basically, this is x to the first power. So you have 1x times 2x's. The answer is x cubed. So whenever you have the number of x's there, you just need to add the powers together. And we'll do some more examples of this right now. Next is 6x times 7x. The trick here is you need to multiply the numbers and the x's separately. So for instance, what's 6 times 7? That's 42. And then what's x times x? That's x squared. Does that make sense to everyone? Everyone see that? Okay, good. And then the last one, why don't you try on your own? I'm going to give you 10 seconds. 3x squared times 4x to the fifth. For those of you watching the recording, pause the video, try it on your own. Okay, and time's up. 3 times 4, again, numbers separately from the x's. So 3 times 4 is 12. X squared times x to the fifth. 2 plus 5 is 7, so it's x to the 7th power. Do not multiply 2 times 5. If you said x to the 10th, that is incorrect. And why is that wrong? Because that's the properties of exponents, which we'll be going more into later around week 6, I think. Any questions on any of those? Okay, good. Now let's do some more examples of distributing. Remember, distributing is just another version of foiling. The goal is still the same. Multiply every combination of things together. In other words, for this one, 3 times 2x minus 6, easy one. You just got to do 3 times 2x, which is 6x, and then you do 3 times negative 6, which is minus 18. There's our answer. Easy as that. Now for the next one, x times x squared plus 5x minus 4. Again, I'm just multiplying across. But I have to be careful here because I'm multiplying by x. So for instance, x times x squared, that's going to be x cubed. Then x times 5x, that's going to be plus 5x squared. And then x times negative 4, what's that? Not that bad, it's just minus 4x. Just like that. Notice we have any like terms that we can combine? No, we do not. So it looks like this is our final answer. Okay, good. Next, number 3. You'll notice number 3 is actually just a FOIL. First, outer, inner, last, just like we saw earlier. So first, 2x times x squared. Remember, numbers separately from the x's. So that's 2 times, and then x times x squared is x cubed. Then 2x times 6. That's going to be plus 12x. Then the inner, negative 1 times x squared, that's going to be negative 1x squared, which I'm just going to write negative x squared. You don't need to write negative 1x squared. And then the last one, negative 1 times positive 6, will just be minus 6. Now the reason why I'm not going to circle this as my final answer is because I like to write the answer from highest degree to lowest degree. So in other words, the right order would be 2x cubed minus x squared plus 12x minus 6. And that's what I'm going to circle. So does that mean the answer over here is wrong if I write it in the wrong order? No, I bet your teacher will accept it on the test. Unless your teacher says write it from highest to lowest order specifically, then you have to do it the bottom way. Any questions on the first three? Okay, and now just one more, the final boss. We have 3x minus 1 times x squared plus 8x minus 5. So why don't you go ahead and try this on your own. Again, I'm going to give you about a minute to do this one. And if you're watching the recording, I'm going to fast forward and just pause the video. So go ahead. Okay, and I'm going to now start going through it. So just make sure you did everything right if you're checking your work. So 3x times x squared, we'll do that first. That's going to be 3x cubed. Next, I'm going to do 3x times 8x, which is 3 times 8 is 24, and x times x is x squared. Next is 3x times negative 5, which is going to be negative 15x. And that's it for the 3x. Now we're going to do the same thing with the negative 1. So negative 1 times x squared, that's minus 1x squared. I'll write minus 1x squared only because I know I'm going to be combining this with that 24x squared in a second. And then negative 1 times 8x is minus 8x. And then negative 1 times negative 5, that's a double negative. It will be plus 5. And now I need to combine like terms and write it from highest to lowest degree. So in other words, the 3x cubed goes first, and that cannot combine with anything. Next is 24x squared minus 1x squared. That's going to be plus 23x squared. Next, I'm going to add the negative 15x and the negative 8x. Notice I'm giving those two underlines each to differentiate it from the x squared terms. Negative 15 minus 8 is minus 23x, and then plus 5, and there's our final answer. Hopefully you got that, or you are on the way to getting that. Any questions on number 4? Okay, then great. Then for the rest of the day, we're just going to be doing factoring. Factoring is what I like to tell people. I like to tell people factoring is the number one skill to know in math from Algebra 1 onwards. Because whether you're in Algebra 1, Algebra 2, Geometry, Pre-Calc, or Calculus, you are going to be using factoring, I promise you. Now, you may have learned this method with like the X. I like to think of that as like the training wheels. In other words, they're helpful at first, but really just like training wheels, you want to take them off at some point so you can use the actual, you can ride the bicycle. So in other words, I'm going to be telling you the method I use. I do not use this method here. I'm going to put a big X through it, which is confusing because there's already an X there. But whatever. Maybe I'll draw it in red. There we go. Look at that. Beautiful. Good thing I was not an art major. Okay, anyways, there's 3 steps to factoring given ax squared plus bx plus c. Number 1, you have to write out the factors of c, all the factor pairs. Step 2, you need to figure out if the factors are going to be both positive, both negative, or one of each. And we're going to get very good today at figuring out if it's both positive, both negative, or one of each. And then step 3, you have to figure out which factors from step 1 add or subtract, depending on what you have, to B, the middle term. So notice step 1 is all about C, step 2 is all about the pluses and minus signs that you have, and then step 3 is all about the B term in the middle. And again, we're going to be doing a bunch of example problems right now with that. Let's go ahead and look at one. So number 1, we want to factor this. We have x squared minus x minus 2. In other words, a is 1, b is negative 1, and c is negative 2. One thing I want to tell you, a lot of kids by mistake, they put like, for instance, they'll say a is 1x squared or x squared. Don't include the x or the x squared in any of the a, b, and c. That's not what you want to do, trust me. So now, what's the step? Well, step 1 said the factors of c. I don't even care about the negative 2 part, just what are the factors of 2? There's only one pair. The only pair of factors is 1 and 2. So that has to be the factors we're using here. Step 2 is we need to figure out if it's both positive, both negative, or one of each. See that minus sign there? See how it's minus 2? That immediately means it's one of each. If it was both positive or both negative, that would be plus 2. We'll see that later. And because it's one of each, that means we're going to be subtracting our factors. So immediately, I know it's either going to be 1 minus 2 or 2 minus 1. That must be the right factors, one of these two. And the way I know which one's right is I need to say, well, what do we have in the middle? What's my b? I would say negative 1x. So negative 1 is what I need. 1 minus 2 is negative 1. 2 minus 1 is positive 1. I want 1 minus 2 because that gets me negative 1. And so the answer is, first what I like to do is I like to set up my x's like this, and then I just fill in the blanks. Like the first blank is plus 1, the second one is minus 2. And there's our answer. By the way, if you do it the opposite order, if you do x minus 2 times x plus 1, this is the exact same thing. They're both right. Notice I didn't flip the signs. I didn't say plus 2 minus 1. I just flipped the order of the factors. That's absolutely okay. Any questions on that first one? Okay, then good. Now on to number 2. Number 2, x squared minus 4x plus 4. So for this one, again, step 1, what are the factor pairs of 4, our c? So that's going to be 1 and 4, and you've got 2 and 2, and there's no others. Now we need to figure out if it's both positive, both negative, or one of each. For that, you look at this guy right here. Because it's plus, that means it's both. But whether or not it's both positive or both negative, you look at this sign right there. And since that's negative, it means they're both negative. And whenever I have the word both, even though they're both negative, I'm going to add them together. And the reason why I'm adding my factors together is because I need to add to a 4, or you can say negative 4. So for instance, what I'm saying is 1 plus 4 is 5, so not right, not right. And then 2 plus 2 is 4, so that's the right one. So it's 2 plus 2, except like we said, they both have to be negative. So it's actually negative 2 and negative 2. So my final answer is, first I'll set up the factors like this, and then I just fill in the blanks. Minus 2, we're done. Any questions on that one? This should all seem familiar to you. Maybe you're not great at it. Maybe you're amazing, but you're not better than me, and that's the important thing. I'm better than everyone. Anyways, number 3. X squared plus x minus 12. Again, factors of 12. You got 3 of them. You got 1 and 12, you got 2 and 6, and you got 3 and 4, and that's it. Next, see how this is minus right there? That minus means one of each, which means we're subtracting. And what do we want to subtract to? Well, we want to subtract so we get 1x in the middle. Focus on the 1, not the x. So if I do 1 minus 12, that's 11, or negative 11, which is not what I want. 2 minus 6 is 4, or negative 4, which is not what I want. And 3 minus 4 is 1, or negative 1. That's the right one. It's 3 and 4. Now it's either going to be 3 minus 4, or it's going to be 4 minus 3. Well, 4 minus 3, that's positive 1, so that's the one I want. So the correct answer is x plus 4 times x minus 3. And there we go. One thing I do want to mention is that you can always check your answer for factoring. Let me show you how. So here's how you can check. So we said the answer was x plus 4 times x minus 3, right? You're going to check by foiling. And we're probably better at foiling than we are at factoring right now, so this should be a walk in the park. X times x is x squared. X times negative 3 is minus 3x. 4 times x is plus 4x. And then 4 times negative 3 is minus 12. You combine the like terms, the negative 3x and the plus 4x, and you'll get x squared plus 1x, or just x, minus 12. And was this the original problem? The answer is yes. And because it was equal to the original, check, we're good. If for some reason it did not match, that means you factored wrong and you got to do it again. Any questions? Okay, good. And now just a few more. How many questions do we have left? We got 4, 5, 6. Okay. So this one I'm going to do on my own, or I'm going to lead, I should say. And then on the next page, numbers 5, 6, and I'm going to add a seventh problem. You're actually going to be trying it on your own. So one more where I lead. We have to figure out the factors of 36. There's a lot of factors of 36. You got 1 and 36. You got 2 and 18. You got 3 and 12. You got 4 and 9. And then you got 6 and 6. That's 1, 2, 3, 4, 5 factor pairs. That's a lot. And this plus sign right here means they're both either positive or negative. And since this sign is positive as well, it means they're both positive. If that was negative 13x or minus 13x, then they'd be both negative. And that's how you know. So anyways, both positive means we're adding these together. And I just have to add up to 13. So 1 plus 36 is 37. That's not right. 2 plus 18 is 20. That's not right. 3 plus 12 is 15. That's not right. 4 plus 9 is 13. There we go. So 4 plus 9 is right. By the way, if you want, like once you get really good at factoring, you don't even have to write out all the pairs. You can stop once you get to the one that you know is right. Like for instance, if I know 4 and 9 adds up to 13, I can just stop there. I don't need to list out 5 factors. But if you're unsure and you want to keep the training wheels on, at least for a little bit, that's absolutely fine. You write out all the factors and you'll get the right answer. So the answer is x plus 4 and x plus 9. And there we go. Any questions on that one? Okay, then in that case, you're going to try number 5 on your own. Don't do 5 and 6, just do number 5. I'm going to give you a minute if you're watching the video. Pause it, and then unpause it when you're ready to see the answers. So go ahead. Okay, time's up. So here's the answer to number 5. Hopefully you got close. So first factors of 12. You got 1 and 12. You got 2 and 6. And you got 3 and 4. The fact that this is minus means it's one of each, and you're going to be subtracting. You need to subtract to a positive 4 in the middle. So 1 minus 12 is 11. Wrong. 2 minus 6 is 4. Yep, it's that one. Now it's either 2 minus 6 or it's 6 minus 2. And since we want positive 4, it's going to be 6 minus 2. So the answer is x plus 6 times x minus 2. And there we go. Hopefully you got that right. Any questions? Okay, next we're going to do number 6. Again, same thing. Do it on your own. And just so you know, I'm adding a number 7. I know it's not in the packet. I'm going to add it at the bottom. You've got a lot of space there. But anyways, go ahead, pause the video if you're watching. And if you're live, go ahead and solve it. And time's up. So here's what we're going to do. First factors of 48. There's a lot. You've got 1 and 48. You've got 2 and 24. You've got 3 and 16. You've got 4 and 12. And you've got 6 and 8. Now the fact that that's positive means that they're either both positive or both negative. And that since that's minus, it means they're both negative. And therefore they have to add to 14 or negative 14. So let's go through them. 1 plus 48 is 49. Wrong. 2 plus 24 is 26. Wrong. 3 plus 16 is 19. Wrong. 4 plus 12 is 16. Wrong. 6 plus 8 is 14. It was the last one. Look at that. And since they're both negative, I immediately know the answer. It's x minus 6 times x minus 8. And there we go. And again, you can always check your answer by factoring and foiling. Any questions on number 6? Okay. And then there's one more I want to look at. I'm going to call it number 7. And I'm actually going to do this one because it shows up in the homework and I forgot to put it in this packet. It's the problem x squared minus 25. In other words, I'm missing a middle term. What do? Well, you're not missing it. It's just 0. In other words, let's rewrite this as x squared plus 0x minus 25. And now it's the same format we're used to seeing. Again, I'm going to figure out the factors of 25. It's 1 and 25 and 5 and 5. And since this is minus, it means it's one of each, one positive, one negative. And I need to add up to 0. Well, 1 minus 25 is 24. 5 minus 5 is 0. Looks like it's 5 and 5. And since one's positive and one's negative, it's x plus 5 times x minus 5. And there's our answer. Now, by the way, I will show you another way of doing this one. This is the way I do it. I don't actually write it out like this because I'm, the factoring master. Anyways, what I do is this is called a difference of perfect squares. Difference of two squares is what this is called. What does that mean? Well, or maybe you don't, but I'm going to tell you, you should know the square root of 25. The square root of 25 is 5. And the square root of x squared is x. Maybe you didn't know that. That's fair. But basically, since they're both perfect squares, and it's difference here means minus. So for instance, if this was plus 25, this wouldn't factor at all. This would actually go into a topic called imaginary numbers, which for those of you who came early, or should I say on time, you would have seen that there was some imaginary number stuff that I had to erase. Yeah, that's problems like this. I don't even think we're going to be talking about imaginary numbers this summer, but you'll probably see it at some point in Algebra 2. Anyways, the answer here, whenever you have a difference of two squares, you take the square root of both, like this, and square root of x squared is x, square root of 25 is 5, and that automatically becomes x plus 5 times x minus 5. So what I'm saying is, for instance, if I had x squared minus 4, well, I know the square root of x squared is x, I know the square root of 4 is 2, immediately I know the answer is x plus 2, x minus 2. Now keep in mind, this strategy doesn't really work well for numbers that are not perfect squares. Let me show you what I mean. If you have x squared minus 10, well then take the square root of x squared as x. What's the square root of 10? Yeah, I don't know either. So technically, this is funny. Maybe you'll get it. Technically, the answer is x plus square root of 10 times x minus square root of 10, which is the right answer, by the way. But this is a little too advanced, I think, for right now, so you're not going to see it anytime soon. And with that, that's going to do it for lesson 2. I know it was a shorter one, but don't worry, next week it will not be shorter. And if you have any questions, you can stick around. If not, I'll see you next week. I'll be posting the recording and the problem set later today. Thank you all for coming, and bye-bye.